Okay, big one today. We're going to deal with the concept of evolution, biological evolution, in its entirety, or as best as we can, I suppose. It's a big, big subject. But it's important that we cover it because we're going to be looking at the evidence for human evolution as remains to us in the archaeological and paleoanthropological record in the subsequent chapters. So we need to understand the theoretical and concepts and the principles of how evolution works, and an understanding of what biology is and how we understand it today in a modern sense. I've explained to you before that we're trying to be objective in this course. We're trying to treat anthropology as a science as much as we can, as a social science which uses the same principles but on social concepts. And what we're going to talk about today is hard science. We're going to talk about facts, and we're going to talk about evidence and theories. Now, I've already gone over what a theory is, and a theory is not a guess. A theory is not a hypothesis. A theory is not to be proven. A theory has already been established as a fact. There is no dispute of evolution. No scientist who is actually following science disputes evolution as a principle, as a concept. And frankly, for the purposes here, you're going to be tested on what we're discussing about evolution as a fact. So I expect you to learn that. That's part of what I am here to teach you and to lead you through the understanding of that. Now, I don't really care whether you have faith in a non-scientific system. You're welcome to have that. That's your choice. But for the purposes of this course, I need you to understand the scientific understanding of biological evolution. And let's take roll the clock back a little bit to sort of contextualize why I feel it's necessary to go over the distinction between biological evolution as we understand it today in a modern scientific sense, and other ways of knowing, other ways of epistemology. In the early part of the 18th century, and before then, there was only one way to know things, and that was to consult the Bible, or at least in Europe and North America and many other places. All sources of knowledge were from the Bible. The church had a monopoly on what was true and what was factual. You weren't allowed to say, I don't think that is true. I don't think that is factual. That was the only place where you got that information. And it was 1755. Actually, it was November 1st, 1755, when an earthquake struck Lisbon, Portugal, the capital of Portugal. Now, Portugal at that time was a superpower. It was one of the great maritime empires. They had colonies from Brazil to Africa to the Oceania and Indonesia, Timor, Asia. They were all over the planet. They were some of the first European countries to make contact with places like Japan. They were a huge powerhouse. They were extremely wealthy, extremely sophisticated, and extremely Catholic. And knowledge of who humans were and where we come from was accepted by everyone to be given to us as information from the church. And On All Saints' Day, November 1st, as good Catholics, the residents of this capital city of Lisbon, which was the center of this huge maritime empire that spread across the world and brought great wealth, everyone was, as they were told to be, in church at about 10 in the morning or something like that. And they were in these big cathedrals and scattered around. And a massive earthquake struck. And if you go to Lisbon today, there is almost nothing that survives that predates 1755, that predates this, the Great Lisbon Earthquake of 1755. Tens of thousands of people were killed. The cathedrals crumbled on top of them. And imagine what that would be like for people in Paris or London or Berlin or Rome, that the other great capitals of Europe and in America too. That like, for instance, could you imagine if a massive earthquake hit New York City or Los Angeles and people died all instantly? Not only that, but Christianity was the accepted place, repository for knowledge. So people on November 1st were where the church told them to be. And this was disturbing on so many levels for people at this time that they looked at this event and they said, how do you explain this? How does the church explain this? We were just doing what we were told, or they were just doing what they were told, and it allowed for people to question the authority of the church, the monopoly that the church had on knowledge. And you had thinkers like Voltaire, that started writing about this event. And it started to bring on a swelling of challenges to the primacy of the church's grip on knowledge. And it's what we call the beginnings of the so-called Enlightenment. Or at least it was a gate, it was a doorway that opened up during the Enlightenment that allowed people to ask questions that previously, prior to 1755, would have been extremely awkward. That thing that was allowed from this time onwards was to say, no, I don't accept that. I don't agree with that. Prior to this event, the stronghold that the church had on knowledge was so powerful that you couldn't say, I don't think that that's true. You only had one source of knowledge, that was the Bible. And this shook their grip and relaxed it a bit. And you had thinkers able to say, there might be another way to know things. Now, one of the locations where this Enlightenment started to pick up in the early 19th century, the end of the 18th, so the late 1700s, early 1800s, was in Scotland, and it's called the Scottish Enlightenment. And you started to have universities and independent thinkers that started to develop some of the disciplines that we understand as academic disciplines today. Prior to this, there was no such thing as geology, for instance. But James Hutton, from my alma mater, University of Edinburgh, started asking questions about what the church said about how old the earth was, for instance. He went around and he looked at the geology in his backyard, essentially in Edinburgh, the capital of Scotland, and he saw that the castle was sitting on top of what to all the world looked like a volcano. It looked like volcanic material. But he's like, no one in recorded history has ever seen a volcano, an active volcano in Scotland. And that castle's been there or buildings have been on there for almost 2,000 years. So how possibly could this be a volcano unless it's extremely old? And that got him thinking, okay, wait a minute, what does the Bible say about how old the Earth is. And actually people had calculated that the Bible says that the Earth was about 6,000 years old. And he says, that doesn't seem right. He started to investigate things like geology with the idea that he didn't have to accept the Bible's chronology, the Bible's timeline, and he went into it with a more open mind. And he did things like look at how long things take to erode. And actually I did, when I was a child, I did an experiment for a science fair where I had a couple of water channels with some soil that I'd put in it, different types of soil, some rocks and things. And I poured water over them at the same rate, and I collected the water at the end to see how much sediment had built up there. And it was different types of soil, different types of rock, deposited sediment in different ways, and that was measuring erosion. How much erosion takes place in different types of soil, right? Pretty simple project that, I don't know what, I guess I might have been 10 years old or something. Pretty easy to do. But the important thing is that experiment that I did in a science fair when I was a child showed me the rate of erosion that takes place on different types of deposits. And this is essentially a principle that James Hutton came up with in Edinburgh as one of the underlying foundations of geology. It's called, in fact, it's one of the underlying principles in all of science, and it's called uniformitarianism. That uniformitarianism is the assumption that the principles that you can measure on a small scale can, in a small scale direct recording of that information can be assumed for places you can't visit or time periods that you can't visit. So in other words, the principles of physics, the laws of nature are uniform, right? So uniformitarianism is that if I can do in my little science experiment, this type of soil erodes at this rate, and this type of soil erodes at this rate, then I can go to something like the Grand Canyon, and I can say, all right, I know the rate of erosion for this type of deposit. How long would it take for the Grand Canyon to erode all of that away? And all you have to do is just do this experiment in a lab, come up with a margin of error, and then you are able to calculate how long things would have taken to have developed. And James Hutton established the science of geology from this basic principle, but it's a basic principle that we use all the time for all types of science. You may read in the newspaper about something like how scientists have discovered some exoplanet in some distant galaxy, or in far reaches of our own galaxy, where they say, okay, there's oxygen and there's nitrogen and there's a sun that's burning helium and hydrogen. And I don't know if you've ever asked yourself, but you might say, how do they know that? How do they know what elements are being burned or being reflected or exist on a planet or on being burned on a star? Well, the basic concept of uniformitarianism, once again. All you have to do is go down to the Las Vegas Strip and you'll see neon signs all over the place. We know, and we can experiment on, and we can repeat over and over and over again, that if you stimulate the atoms of a particular element, it is going to burn with a certain particular frequency of light that we can measure. So it'll be green, or it'll be red, or it'll be blue. And it's always the same. You can go to a laboratory and you can measure it and measure it again and again and again and again, and it will always be the same. So what happens on a small scale, burning a tiny little fraction of helium or hydrogen in a laboratory, you can then say, all right, point your telescope to a burning or reflecting object in a distant part of the galaxy and say, I'm getting that same frequency of light, and I know what is being burnt in the lab, so that's what must be applied on that distant planet. So you don't have to travel to that distant planet because the uniformitarianism exists. That the same principles that exist here in our lab exist way out there in space. Also, for geology, the principles that exist today also existed in the distant past. So these are the sort of things that started to challenge the biblical timeline, 6,000-year-old Earth. And James Hutton, in his lifetime, proposed that actually the Earth, because of the principle of uniformitarianism, and he saw erosion taking place, he said the Earth must be billions of years old. And as it turns out, it's more than 4 billion years old. And life, we now know, is about 3.5 billion years old. Maybe not quite that old, but 3.2 maybe, something like that. Prior to the Enlightenment, the only accepted explanation for life and creation of life was creationism, the biblical narrative. Forget for a moment that the Bible actually has 2 creation stories, and the Bible's not the only game in town. There's other religious texts. So you're choosing one to believe and others to reject. And most importantly, it is not science. And the reason why it's not science, if you recall a previous lecture, is because you have to be able to say no. You have to be able to say, I think this is the way the world operates. If that's the case, then this is what I should expect to see. Now, that if-then testable hypothesis is very important, but if you're not allowed to say, no, my hypothesis is wrong, then you are not doing science. And creationism is a way of thinking about things that does not allow you to say no. You can't look at the Bible and say, no, okay, not that part. Or at least a literal reading of the Bible does not allow for that. So science and the creationism cannot be science because it is assuming that there is an unimpeachable narrative from the Bible that cannot be questioned. You cannot say no to it. So why am I talking about the Enlightenment and Scotland, apart from the fact that that's where I did my training? Well, there was a young man who came from a learned family, a fairly middle-class but well-to-do family in England, and they sent this young man to the best medical school in the world at the time, the University of Edinburgh. He wasn't particularly interested in doing medicine, but he was interested in science. He was a very curious and interesting person, and his name was Charles Darwin. Charles Darwin went to medical school at the University of Edinburgh, where he would have learned about, from a previous generation, James Hutton, but contemporary with him was Charles Lyell, one of the other founding fathers of the science of geology. He also was learning about biology, as in learning about medicine at the University of Edinburgh. And so he was learning about biology, he was learning about the antiquity of the past. Also, there was popular writing going on by people like Thomas Malthus that had been talking about things like the word evolution was already being used by everybody. Charles Darwin did not make up the word evolution. He didn't make up the concept of evolution. Evolution was already an accepted concept in social descriptions. That Thomas Malthus was talking about how society evolved and changed through time. And it's something that all you have to do is pick up a history book and you can see that we've gone through stages of social evolution. We've changed. We have gradually transformed from one type of community into another type of community. This was not a mystery. But no one had applied the concept of evolution to the development of biological organisms. And it wasn't just Charles Darwin who just sort of invented this concept. If it wasn't Charles Darwin, it would have been somebody else who would have come to this. And in fact, we even have the name of the person who it would have been. His name was Alfred Russel Wallace. And we know this because at about the time that Charles Darwin was publishing his book, about to publish his book on the origin of species by means of natural selection, Wallace wrote him a letter saying, "Oh, I hear you've been working on this concept. Here's what I think about it." And Darwin's like, "Uh-oh, I better publish quickly because he's gonna beat me to the punch." So Wallace would have done it if Darwin didn't. And in fact, they seem to have gotten along okay. And their first presentation to the Royal Society was a joint lecture that they gave. So they actually worked together. But the reason why Darwin is remembered as an important figure is because he was the right person at the right time and in the right place, as it turns out. So he was at the University of Edinburgh when he was approached to go on a really amazing opportunity, a voyage around the world on a very famous ship called the HMS Beagle. And it was a voyage of discovery, and he was employed to be the ship's naturalist. So his job was to observe nature, to describe it, to draw it, to collect samples, and then to eventually publish it. And this was, I can't remember exactly how long, but it was more than a year of his life. And he went to some places that no human had ever been to before. Like, for instance, the Galapagos Islands, which are now quite famous, but they're famous because Darwin described what he saw there. And what Alfred Wallace and Charles Darwin, what differed between them is Wallace was thinking about these ideas, but Darwin had these discoveries he had made, and all of this data that he could work on from his trip around the world on the Beagle. So Wallace didn't have as much data as Darwin did. And the thing that's really amazing about his publication on the origin of species by means of natural selection are twofold. One, his concept is extremely influential, and it made sense of a lot of things that people were sort of just not able to get a hold of. And he was able to sort of nail it down and say, all right, here's the way this theory, this framework works. And it still holds true. But the other thing is that he was able to demonstrate with copious evidence of the way that it worked in real life. Also at this time, he was aware, and in the United Kingdom, at this time, the